Hi guys, welcome back. So in the next few episodes, we'll be doing this May-June 2025 Integrated Science Paper 2. It will be the same as the previous past paper done, where each question will be uploaded as an individual video. And yeah, so let's begin. So number one, or question one. So A. Water is a unique substance because it exists in three states. Figure 1 shows the arrangement of water particles in the three states of matter. So you have X, Y, and Z. 1. Identify the three states of matter labeled X, Y, and Z in Figure 1. So looking at the structures or the arrangements of these particles, it should be very simple to identify that the more solid structure would be solid. The structure that it isn't fully structured but just laying around or showing that it is taking the form or the shape of the container that is liquid. And of course, this one will be a gas. So 2. Identify which one of the states of matter labeled X, Y, or Z best represents the arrangement of the particles in ice. Ice is something that is solid, thus it would be X. 3. State the name of the gas that is formed when heat is applied to water. That would be water vapor. Then we have part B, which aligns with this graph here. So I'll show the two at the same time. Just get it around a bit more. Right, perfect. So B, the table below shows data collected from an experiment where heat was applied to ice. So you have the table with the data that was collected, you have time in minutes, and you have temperature in degrees Celsius. So you have time ranging from 0 to 38 minutes, and you have the temperature going from negative 20 degrees Celsius all the way to 120 degrees Celsius. So part 1 asked us, on the grid provided on page 7, plot a line graph of time against temperature to represent the data in table 1. You must connect each plotted point and label each axis. So this would be 10 marks. So you would get 10 marks once you have plotted all of your points correctly, as well as labeled your axes. And I also added the title to a graph because your graphs should always have titles. So it is literally temperature against time. So graph showing temperature versus time. Now, when it comes to figuring out what needs to be on your x-axis and your y-axis, some students may get this a bit confused because usually, according to what you are doing, temperature may be, both time and temperature could be on the x-axis. Also, always remember your x-axis is at the bottom while your y-axis is going upwards. So when it comes to figuring out what is on your x and y axis, what you have to ask yourself is what changes. So what remains constant and what changes over that particular period, in this case, period of time, right? So it is not that as temperature increases, something differs with time. Time is not being affected by the temperature. What is happening is as the time goes by, the temperature is increasing because remember what you are doing is heating ice over time. So the temperature is increasing. So thus, the time is influencing what is happening with the temperature, or if not influencing, you can say that it is affecting what is happening with the temperature. So time will go on your x-axis, while temperature, which is the factor that is being influenced, is going to go on your y-axis. In this case, it was easier to figure out. Sometimes they could just give you this blank and you have to figure that out. But as a hint, which I would say kind of gave away the answer to you or part of it, they already plotted the axes for you. So it's pretty simple for you to say, okay, well, we only went up to 38 for time, so time is going on the x-axis, while on the y-axis will obviously be temperature because it's going all the way up to 130. So you plot all of your points. I have them in red, so you can pause the video to see if you did the question, if it aligns with what you had. Your axes are there, your labels, as well as the label for your graph, 10 marks. So part 2. Using the graph drawn at B1 on page 7, determine the time at which the temperature of water was 70 degrees Celsius. So this would just be simply to read off of the graph that you had. You had to connect all of your points using, because this is a line graph. So you just go from 70, you go across until you meet the line and then you come down. So where that intersected the line was at 20 minutes. So 20 minutes would be your answer. Part 3. In another experiment, heat was applied to ice and then the container was covered for a few seconds. When the lid of the container was removed, water started to drip from it. So explain why there was water on the lid of the container. So if heat was applied to the ice would have melted. So going from that solid state to a liquid state, so from ice to water. Then you continued adding heat to it, so the water would have begun to boil. It would have reached its boiling point. When it reaches its boiling point, remember energy in terms of kinetic energy now is being given to the water molecules, and eventually they are going to break free of their bonds if they have enough energy. So when they are broken, or when at least the this will happen at the surface first, this is where you have the vapor or steam that is going to be produced, and those particles are going to rise. There was a lid that was covering it, thus there was nowhere for it to escape. So when it hit the lid, or when the vapor or the steam got to the lid, the temperature difference, it cooled, returning or changing from that gaseous state back to its liquid state through the process which is condensation. And this is what would have accounted for the fact that there was water on the lid of the container that started to drip from it. And we have the last part. So figure 2 shows two classes of levers. You have lever X and you have lever Y. One of the levers has a mechanical advantage of 200 and the other lever has a mechanical advantage of 10. So you have lever X and you have lever Y. Just get back a laser pointer. Right. So you have lever X, you have lever Y. With this, they are telling you have two classes of levers. So this now needs you to pull on your memory that you have three classes of levers, and the classes of levers are based on the position of the effort, the fulcrum, and the load. So 1, outline why lever Y would most likely be the lever that has a mechanical advantage of 200. Now, looking at the two, you should be able to say, okay, well, the effort is at the bottom, the load is at the top, you have the fulcrum on the end. While for X, you have the effort at one end, the load on the other end, and then, sorry about that, you have the fulcrum in the middle. So how do you identify, or what types of levers are these? They told you it is two classes of levers here. So you should remember, once you have the fulcrum in the middle, how you see it is EFL or LFE or whatever, how you want to state it. This is your first class lever. And this here, where you have ELF, where you have your effort, you have then the load and the fulcrum at the end. This is your class 2 levers. It is important to remember that your class 2 levers are always going to have that a higher mechanical advantage because class 2 levers are multipliers of force, therefore making things easier when it comes to lifting. So the effort moves greater distance than the load. And this is simply your answer there. So 2 marks. It could be a very easy 2 marks once you remember the types of levers that you have and the advantages of each type of lever. Number 2. So using the formula, mechanical advantage equals load divided by effort, calculate the mechanical advantage to lift a load of 3,000 newtons when an effort of 300 newtons is required. You didn't have to do much thinking for this. They already gave you the formula, so you just do the division and your answer will be 10. Please remember, when you are talking about the amount mechanical advantage, it has no unit, so it's just 10. Please do not put newtons at the end of that. And then you have number 3. Using the formula, work done equals force multiplied by distance. Calculate the work done by the lever to move the 3,000 Newton load at distance of 0.1 meter. Again, you do not have to do any hard thinking. They already gave you the formula, so you just do the multiplication, and what you will get is 300 Newton meters. And remember that Newton meters is the same as joules. So that would be it. At the end, once you got everything correct, you would have acquired your 25 marks.